All right, so today we're doing 9.5, the volume of pyramids and cones. All right, so we have Cavalieri's principle. We talked about this last week, didn't we? No? Okay. So my apologies then. I was thinking we already did it. Maybe it's a different class. So for any two solids with the same height, if all planes are parallel to a fixed plane, form sections having equal areas, then the solids have the same volume. Okay, I was going to say, we talked about it last week, so it's just a reminder. Thank you for making me feel crazy. So this principle works for both right and oblique pyramids and cones. So I brought it back up today for us to use. All right, so our theorems, we have the volume of a pyramid, first of all, is 1/3 the product of its height and the area of its base. Okay, so V equals 1/3 BH. The volume of a circular cone is the same thing. It's 1/3 the area of the base times the height. 1/3? Or, like, because it's a cone, we can replace that area of the base with the pi times the radius squared, the area of a circle. Right? Like, this is the B because it's the formula for the area of a circle. Okay, just like for our pyramid, depending on if it's a triangular pyramid or hexagonal pyramid or a square pyramid, that formula for the area of the base is going to change. All right, so we're going to dive right in. Example 1. Find the volume of the 321-foot tall Memphis pyramid, which has a square base with sides measuring 591 feet. Okay, so there's some important information in here, but don't forget one important piece is the fact that this has a square base. That's very important for us.
Are we just doing word problems?
Yep.
Why?
Because word problems are the best.
Okay, yeah.
This is why you're homeless. This is why you're homeless.
This is why Donnie is a better teacher.
Okay, fair enough. All right, so volume of a pyramid is 1/3 the area of the base times the height. Okay, so we need to find the area of the base. So how do we find the area of our base? What shape is our base? A square. So how do we find the area of a square?
Oh man, that's a big number. The base equals 3, 4, 9, 2, 8, 1.
Okay, but how do we find the area of a square? How did you get that?
Because one of the sides is 591.
Okay, right, its sides measure 591. So the side equals 591. To find the area of a square, we take the side and we square it. So it's 591 squared, which equals, what'd you say, Lucas, or Caden?
349,281.
Can anybody confirm that?
Yeah.
Well, you're the one that gave it to me. 349,281 for the area of our base.
Can anyone confirm that?
No, because you're wrong.
Because I didn't do it. He is not wrong.
He is not wrong. Okay, so now we have our area of a base. Okay, that's the intermediate answer we need. And we need the height because we're finding the volume. Do we know the height?
Yes.
Yes? What is it?
321.
It's 321 feet tall. That is the height. So our volume is going to equal 1/3 349,281 times 321. I should have moved it on down. So what does that equal?
You can divide it by 3 to get the 1/3, right?
You can divide it by 3. You can do 349,281.
3737067.
37370. What'd you say? Or 373?
3737067.
3067. Okay, and what's our unit?
Feet cubed.
Feet cubed. Good, because it's volume. We multiplied. So 37,373,067 feet.
That's
cubic feet. Yeah, it's a giant pyramid in Memphis, Tennessee. I had to look it up. I was like, what? I didn't know there was a pyramid. It's Bass Pro Pyramid.
I know.
I stayed in it.
Well, now you know the volume of it.
Like the top. Okay, so they have a shop. There's the shop, the restaurant, the people where they stay, and there's another restaurant for the people that stay there. I stayed there when I was on my way back from Florida.
Cool. All right. So yeah, I had no idea. But yes, it's the Bass Pro Memphis Pyramid. All right. Example 2. Find the diameter of the mouth of a 15 centimeter waffle cone with a volume of 250 centimeters cube.
That's in Memphis.
What?
That'd be fun. Okay, so what shape is a waffle cone? Like, what's the shape of the base?
A cone.
It's a cone. Okay, so we're looking at a cone which has a circular base. We are finding the diameter of the mouth. So that's where they put the ice cream in, right? It's 15 centimeters tall, waffle cone. So what's that? The height, okay. With a volume of 250 cubic centimeters. So we have our volume. Well, okay, so we've got volume equals the area of the 1/3, pardon me, the area of the base times the height. It's the same formula. This time we have a waffle cone, so the area of the base is a what shape?
Cone.
Circular one. So we could also say it's this one. So let me put or v equals 1/3 pi times the radius squared times the height.
Would you have to do that since you can't find the base?
Right. Well, if we found the base, it would be like we would find the base, but it might be a longer number. We could do either, technically, but
Which one would you do?
I would go ahead and do this one.
Oh, I know you were gonna pick that one.
Yeah. Well, it's fewer steps in this way in a lot of ways. Okay, so 250 is our volume, equals 1/3 pi times our radius squared times the height.
So 3, would you do 3 times?
Well, I would go ahead and do 1/3 of 15.
So it'd be 5.
Okay, so 250 equals 5 pi times the radius squared.
So then divide the 5.
Yep. Well, you could divide by 5 and pi at the same time.
Which equals...
I got probably a number different.
What's 250 divided by 5? Or you could look at them as canceling.
50.
Right, this would be 1 and this would be 50. So then we'd have 50 over pi equals the radius squared.
Oh,
So
yeah.
then divide it by 5.
Well, no, it won't do any. I mean, if we're just going to get a decimal, you could get the decimal, but then how would you solve it?
By solving it.
Would you square it?
It's already squared.
Square root.
Square root, right? Because we already have r squared, so we have to take the square root. So what is the square root of 50 divided by pi?
Approximately 7.07.
No.
Yes. Yes.
That was good.
The square root of 50?
Divided by pi.
Yeah.
How did you? No, you probably did the square root of 50
I did.
and then divided by pi.
Yeah.
That's not the same thing.
Yes.
No. It's the square root of 50, the quantity 50 divided by pi.
Oh, I kinda. No, but I did it differently. I brought the pi in after.
It doesn't work.
Why?
Because you can distribute that and say what's the square root of 50 divided by the square root of pi.
So why wouldn't that be it?
Nope, because you have the answer there. So it's see how it has the answer? Like that, it's making that your cube, like your root. Okay, I'm going to pause this while we work with our calculators and figure out how to do it. You're right, we bypassed this. Okay, so we got our radius to equal 3.99, and then to find our diameter, we said diameter equals 2 times the radius, which was 7.98 or 8, depending on how you round it.
Homeschoolers gonna be like, where did that come from?
My homeschoolers.
You mean Lauren?
Yeah, that's what I meant.
Oh, okay, I was like, I don't know. Okay, so any questions on this one? All right, then let's go to example 3.
Woo!
Make it all go
Oh,
away.
that smells funny.
All right, we're going to find the volume of the oblique pyramid
I don't think we should.
with a regular base, and dimensions are in feet. What is important here? What word?
Oblique.
Regular.
Actually, oblique doesn't really matter. Oblique is very important.
Okay.
Okay? The fact that it's a regular base. Because a regular means what?
I'm so smart.
Not you.
Oh, okay. Yeah, she's so list.
Right.
I don't mind the teasing and the joking, but I do want real answers. Or we can also take notes out of the book.
It's like
I know regular means like no, but what does that mean in mathematical terms? Like regular is specific in math. It's not like saying somebody's normal or you wash your laundry on the normal cycle. Like what is
Original.
not the original? That's not what regular means. Okay, regular, when it's telling you it's a regular base, it's a regular shape, it's a regular polygon, all the sides are equal.
So square.
So what?
no.
No. In this polygon,
So
Okay.
you could call it an equilateral base.
Yeah.
is an equilateral base. Yes, you could call it that. So, like this base, how many sides do you have on that base?
6.
7. Okay?
So
Not 7 times 7 times 7.7. Okay? Because all the sides of that polygon down there are equal. All 7 sides. So yes, but that's the thing about regular. That's why I continue to point it out every time we get there, is so that you remember, if it says it's regular, it means all the sides are equal on that shape. Okay, so what is 7 times 7.7?
53.9.
53.9? Okay, what's that? What is that? Do we know? What did you just find?
Perimeter.
The perimeter. Okay, so that's your P that's going to be necessary eventually. Okay, so how do we find the volume of this pyramid? It doesn't matter if it's oblique, right? Cavalari's principle said it doesn't matter if it's oblique or right.
1/3 base.
Okay, so V equals 1/3 the area of the base times the height.
So 22 times 53.9, but you can
So 22 is our height. Is that what you're saying? Okay.
Ooh, it's the decimals.
All right, but what about the area of our base? That's where we generally we always have to go back to. How do
Base equals 1/2 apothem P.
Okay, so the area of our base here equals 1/2 the apothem times the perimeter. Because it's an n-gon, right? The area of any regular n-gon is 1/2 the apothem times the perimeter. Do we know the apothem?
yes.
8.
It is 8, and we found the perimeter.
So 4 times.
So 4 times 53.9. Good.
And I have a weird decimal.
Okay, what'd you get?
1581.06 repeating.
That wouldn't be right.
215.6.
215.6 is. Let me look at what you put in your calculator.
No, for the end.
Oh, for your final answer?
Yeah.
Oh, okay. All right, so now we're ready to put our base into this formula. So our volume equals 1/3, 215.6, and what'd you say our height was?
Times
22, because that was over here. All right, so our volume equals, what'd you think it was, Caden?
1581.06 repeating.
1581.06 repeating, so what would,
067.
okay, so let's round that on.
07.
Okay, so we could say 1581.07, 1581.1, however, is fine with me. What's our unit?
Feet squared. Feet cubed.
Feet cubed.
So what's the point of the cubed and the squared?
So, for these?
Yeah.
Okay, so squared tells you that it's something that fills in a square amount. Right? So it's surface area. It's the surface of something. Where a cube, if it's a cubic measurement, it literally tells you how many cubes it would take to fill that space.
So the squared and the cubed for like when you put it for feet, that just tells you kind of what you found.
Yes, if it's volume, it's always cubic.
Yeah.
Area, surface area is always squared.
So like if you don't have V and you just put 1581.07, if you did cubed, somebody would think it's just normal area.
You mean if you put cubed,
Yeah.
then they would think it was
Squared.
volume. If you put squared, they would think it was area. Yeah, correct.
So it doesn't really do anything. It's just kind of saying.
It tells you the type of dimension, and because we know the type of dimension, then we should know what we found, whether it was area, surface area, volume. But like squared, it's harder because you don't know if you're finding surface area, lateral surface area. There's a lot more types of area.
Well, yeah, but it's all areas. Too.
But it is all area, yes. All right, so on to the back.
What back?
All right.
We have a back.
So we have some formulas for the volume of your platonic solids. Okay, so remember the volume of a solid for which you do not have a known formula can frequently be found by separating the object into solids whose volumes can be found with known formulas. Then we get to use the volume addition postulate to find the sum or difference of those volumes, which is what we get to do on example 4. We're going to find the volume of the solid, and dimensions are in millimeters. It is exciting. All right, so let's call this shape up here A, and then the middle one we can call B, and the one out here we can call C.
Let's do C first.
So when we do the volume of, we're going to go in alphabetical order, man.
No, we should go in.
Reverse alphabetical order. That's no fun.
You described this. You said the one in the middle we'll call A. You called it B.
No, she said
Oh, the
the
one-
top one.
yeah.
A.
She said the one in the middle we'll call A.
No, I said
Yeah,
let's
you
call the
did.
top one A, the middle
No.
one will be B.
No. you
Okay.
said one.
Anyway, so how do we find the volume of this rectangular prism?
So, base times height.
We need 3 dimensions. It's volume. Base times height times
Width.
width.
But he's
Okay, so or length, width, and height. Okay, so what are the length, width, and height of?
224.
Okay, so we've got 2 times 2 times 4.
so 16.
32.
Goofy. All right, so 16 it is for our area of A. Let's look at the volume of A. Let's look at the volume of B. Okay.
Would you take the 6 from C and the 2?
You would.
So it'd be 8.
Yes, because this 6. Uh-huh. Yep, so that 6 plus 2 makes that an 8. So it's 8 cubed, right? Which we could have used this formula up here for the hexahedron, right? It's the edge cubed, either one. So what is 8 cubed equal? Not 256.
Yes.
No.
I did put. No, it's. Never mind.
What is it?
5.
512.
All right. 512.
No.
Okay. How about the volume for C? No.
No, it would be 5.
Okay. How about the volume for C?
So
6?
take 3 off the 8 of the height because it goes up in the back and it says a 3. So
Okay.
use off.
So right, so this whole height here, he's saying this whole height, that's terrible, is 8, but this was a 3, so that makes this a 5. Nice.
So
5 times 10 times 6. 300.
yep, what he said.
All right. So now I found the volume of each of these individually. What do I do to find the total volume?
He had them all
I add them all together. That's that volume addition postulate. So we're going to have 16 plus 512 plus 300.
828.
Your skills are off today. 828. And what's my unit of measurement?
Was it
Oh.
millimeters?
Millimeters what?
Cube?
Cubed, because it's volume.
You're off today.
I had a random mark.
Do a little dance. Good. Okay, so it is 828 millimeters cubed. Very good. Again, like, I don't care for your intermediate answers, you never have to put labels. You just need the 1 on your final answer. Okay? Always remember, that's one of those things you guys keep leaving off. All right, that's it. You can get started on homework.